Welcome all to today's lecture. Myself Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The lecture series that I am covering is for the subject Embedded System, which is an open elective. Subject code is KOE 062. Today in this lecture I will be discussing about the interrupt routines in RTOS, that is real time operating system. So, we will discuss that how the interrupt requests are handled in case of real time operating system. First of all, we will try to understand that what is an interrupt. A hardware signal that initiates an event. So, this is an interrupt. When the main program is going on and in that case some external event has occurred that triggers the interrupt. Upon receipt of an interrupt, the processor completes the instruction being executed, then it saves the program counter so as to return to the same execution point. The third step is it will load the program counter with the location of the interrupt handler code and it will then execute the interrupt handler. What are these steps? That suppose the interrupt has arrived during the execution of the main program. Now, the program will be terminated here after the next cycle. Now, the contents of the next memory location which was going to be executed, it will be currently stored in program counter. So, the contents of the program counter will be saved to some location, say suppose it will be saved to the stack location. Now, thirdly, it will then there must be some interrupt service routine, that is the ISR. So, the interrupt service routine is a subprogram which is executed in response to the interrupt arriving as an event. So, the memory location of the interrupt service routine will be saved to the PC, because when the execution control will go back to the main program, then the address memory location of the main program should be retrieved, and it will be retrieved when it will be saved to some location. So, it is saved. Now, the program counter should hold the address location of the next instruction to be executed. So, now we are going to execute the interrupt service routine. So, the memory location of the interrupt service routine should be saved to the program counter. So, whatever is stored in the program counter will be executed next. So, since the memory location of the interrupt service routine is saved to the program counter, so the routine that is written in the interrupt service routine will be executed, and then after the return from that ISR, then it will go to the main program, and after this the main program will again be executed from the place where it has been left off. So, this is a whole process which is executed when some interrupt occurs to the processor. In practice, real time systems can handle several interrupts in priority fashion. Interrupts can be enabled or disabled. Highest priority interrupts are serviced first. So, interrupts are there when there are multiple interrupts available in the system in the CPU. So, the interrupts are executed according to their priority. So, these priorities are set in prior, and so the execution takes place according to the priority of the interrupts. So, when we talk about the interrupt service routines in the real time operating systems, so there are certain interrupt source calls, and interrupt service routines have the higher priorities over the RTOS function calls and the tasks. So, interrupt service routines should not wait for a semaphore, mailbox, message or queue message. So, that is the interrupt service routine is having the higher priority over all these semaphore, mailbox, message or queue messages. Even ISR is having the higher priority over mutex. It will not even wait for the mutex, as else it has to wait for other critical section codes to finish before the critical codes in the ISR can run. So, this is not good for the system, good for the interrupts. So, interrupt, that is the ISR, will not even wait for semaphore, it will not wait for message queues, it will not even wait for mutex. Semaphore is a signaling function and the mutex is the controlling function, that is a locking function. It will lock all the tasks during the execution of the routine. Now, there are three alternative systems for the RTOS is to respond to the hardware source calls from the interrupts. So, there are three alternative systems for that. First one is direct call to an ISR by an interrupting source. So, there is the direct call will be sent to the interrupt service routine by the interrupting source itself. So, this is the first option. Second option is RTOS first interrupting on an interrupt, then operating system calling the corresponding interrupt service routine. So, this is another option. Third option is RTOS first interrupting on an interrupt, then RTOS initiating the ISR and then an ISR sending the message to IST. So, we will have a look at all these options one by one. First of all, we will discuss the first option, that is the very basic way of answering the routine, that is the direct call to an ISR, that is interrupt service routine by an interrupting source and ISR sending an ISR enter message to the operating system. So, let us see what is happening in this. This is the operating system and this is where the interrupt has occurred. Now, we will go step by step. On an interrupt, the process running at the CPU is interrupted and the ISR corresponding to that source starts executing. So, this is step 1. So, here the interrupt arrives, the main process gets interrupted and the ISR corresponding to that source starts executing. So, this is the ISR. It will this is the ISR, it will start executing. The hardware calls, source calls and that the hardware source which is interrupting the main program, it calls an ISR directly. The ISR just sends an ISR enter message to the RTOS. So, in the very next step, so this is the ISR we can see. So, this is sending the message to operating system, that is the ISR start message. ISR enter message is to inform the RTOS that an ISR has taken control of the CPU. So, this is the second step. Now, we come to the third step, that is ISR code can send into a mailbox or message queue. So, in the third step, the ISR code will be sent in the message box or the mailbox. So, this is the third step, but the task waiting for a mailbox or message queue does not start before the return from the ISR. So, this is the fourth step. Only after the returning from the ISR, the tasks which are waiting for the mailbox or message queues will be started, otherwise the main ISR interrupt service routine will be executed first. So, this is the whole scenario of this type of answering, that is a direct call to the ISR, that first of all this is the ISR, this is the operating system. Now, at the first step when the interrupt arrives, the codes of the ISR starts executing and it sends the ISR start message to the operating system. After this, the ISR code will be sent into the mailbox or the message queues in the third step, and the fourth step is that as soon as the ISR, there is a return from the ISR, that is the execution of the interrupt service routine gets over, that the task waiting for the mailbox or the message queues will be operated. So, when the ISR finishes, it sends the exit message to the operating system. So, on return from the ISR by retrieving the saved context. So, whenever we go from the main program to the interrupt service routine, the context of the previous programs is stored somewhere. So, the saved contexts are retrieved. The RTOS later on returns to the interrupted process, that is the task, or reschedules the processes or tasks. So, it will return to the main program, it will reschedule again for the newer processes to take place. Now, the RTOS action depends on the event messages, whether the task waiting for the event message from the ISR is a task of higher priority than the interrupted task on the interrupt. So, again the priorities will be compared, and if the task which was waiting for the event message from the ISR is a higher priority task, then it will be executed first as compared to the ISR routine. So, in this way, so this whole process takes place in this type of answering to ISR. Now, we will have a look at the example. Assume that a microcontroller timer programmed to interrupt every 10 milliseconds. Timer interrupt calls and program counter changes to an ISR vector address, that is ISR timer address. At the ISR timer address, there is a routine ISR timer for the servicing the timer interrupt. So, this is the scenario. Now, ISR timer first executes OS int enter. This is a function which is being executed by as ISR timer just after the start of ISR timer. Now, ISR timer then executes OS int exit before the code for return. OS int enter, this is the function which will send the message to RTOS that there should be the return from the ISR only after a system call is made by the ISR. So, what is the system call? That until the OS int exit, which is a function, it executes in the ISR code. Then only the message to the RTOS will be sent that then only the return from the ISR will take place. So, this is what is happening in this example. Any task waiting for the post of semaphore or mailbox message or queue message should not start on execution of the post function within the ISR or in any other task or ISR. So, until unless the higher priority ISR gets over, it gets executed, then after the execution, the completion of the execution of ISR, then only the other tasks will take place. There can be a situation of multiple ISRs nexting. So, in this the ISR low priority sends on higher priority interrupt the ISR interrupt message, which is known as ISM, to the OS to facilitate the return to it on the finishing and return from the higher priority interrupt. So, this is a scenario that there can be a nesting of the different ISRs one into the other, and it depends on the priorities of the interrupt service routines, that which interrupt service routine will be executed first and which the later on. So, the nesting means that when an interrupt source call of higher priority, for example, sys clock interrupt. So, this is having the higher priority task, and the interrupt source call occurs, then the control is passed to the higher priority, and on return from the higher priority, the lower priority ISR starts executing. Each ISR on letting a higher priority interrupt call sends the ISM to the RTOS. ISM is ISR interrupt message. So, on whenever a higher priority interrupt whenever the higher priority interrupt occurs, then interrupt service routine first of all will send the message to the operating system, and it will intimate about the arrival of the interrupt on the higher priority, and that is the higher priority interrupt. So, the common stack for the ISR nested calls is available, and which is similar to the nested function calls. So, for all the interrupt service routines which are used on the which are nested with one another. So, in case of the interrupts nesting, so there is always a common stack which is used by all the nested interrupts. Next way of answering the interrupt calls is that RTOS interrupting the first on an interrupt, then RTOS calling the corresponding ISR, that is interrupt service routine. Let us have a look at this scenario. On interrupt of a task, say kth task, the operating system first gets itself the hardware source call. So, this is the step 1. So, in the step 1, this is the step 1. So, whenever there is an interrupt or say kth task is being interrupted, the operating system first gets itself the hardware source call and initiates the corresponding interrupt service routine after saving the present processor status, that is the step 2. So, in step 2 it will save the context. So, as I have already discussed that before switching on to the interrupt service routine, the context must be saved so that it is easy to come back to the main program which was being interrupted before. So, it is very important step to save the context. Then the ISR during execution then can post one or more outputs for the events and messages into the mailboxes and the queues. So, the ISR can send the messages or the events that one or more outputs for the events and messages into the mailboxes or the queues. Now, an ith interrupt source calls causes the operating system to get the nodes of that after step 1. Operating system finishes the critical code till the preemption point and calls the ith ISR, that is ISR I. This is the step 3. So, now what will happen? What is the preemption point? Let us understand that it is the last instruction of the presently running operating system function, after which the ISR being of the highest priority is called. So, here the ISR which is having the highest priority, it will be called after the preemption point. The ISR can post the event or mailbox messages to the operating system for initiating the jth task or the kth task after the return from the ISR. So, and after retrieving the jth or the kth context. So, in this way the ISR can post, that is the 5th step. So, in the 5th step, after the returning, this is the return step, and after returning from the ISR, that is the interrupt service routine, the ISR itself can post the events or the mailbox messages to the operating system. So, at every step we will see that the operating system is being informed of the processes taking place. So, as soon as the interrupt service routine was entered, then the operating system is informed about the ISR start message, and here again on the return the operating system is informed for initiating the jth or the jth task or the kth task depending upon the priority. So, after the returning from the ISR, the context related to the jth and the kth tasks are retrieved and the message is sent to the operating system for initiating these tasks after the return from interrupt service routine. So, this is step 5. Now, the system priorities are ISR and then the task or the ISTs. So, in this way the very first priority is given to the interrupt service routine and then the other task or ISTs. The IST is just a task or signal or message from an ISR. So, this is how the process takes place. Now, we will have a look at an example of mobile device. In this, each device event has the codes for an interrupt service routine. So, whatever functions we see in our mobile phone, these are all the nested interrupts. So, suppose we are using our mobile screen and we want a display of all the contact names on the mobile screen, then we will touch the screen, we will touch the icon. That particular icon will inform the display option and that the display system to display the call, display all the contacts. So, in this way what is happening that we are just interrupting the a certain running program through by touching the icon. The icon will then inform the another the operating system for using the display system. Now, in this way all the systems within the mobile phones are interconnected and we do not know that. We are just touching the icon and all the process of displaying the contact list, the accessing the contact list, accessing the database, these all processes are taking place in behind the system. So, these are all nested interrupts. Each device event has the codes for the interrupt service routine which executes only on scheduling it by the RTOS and provided an interrupt is pending for its service. Now, we will assume that using an RTOS, the touch screen, that is touch screen interrupt service routine, this is just an interrupt that we are touching the screen, we are controlling some, we are trying to open some icon, this is an interrupt for the RTOS. So, ISR touch screen, this is an ISR, has been created using a function OS ISR create. The ISR can then share the memory heap with other ISRs. A function int connects the touch screen event with the event identifier in an interrupt handler, that is ISR handler. So, in this way all the functionalities are related to each other and so we are able to let the mobile display the list of contacts or do any other work we want it to do depending upon the nested interrupts. So, in this way this process is accomplished. So, when a touch screen event occurs on tap at the screen to select the icon or menu, the operating system sends the signal on behalf of the interrupt handler to the waiting ISR touch screen. So, ISR touch screen runs on an interrupt call message, then again ISR touch screen executes as per its priority IST touch screen priority among the other pending ISRs before it starts executing. So, in this way related depending upon the priority of the various interrupts. So, the particular interrupt execution takes place. Now, before return from the ISR touch screen, it sends a message to the kernel using a function OS event post or OS ISR exit just before the end of codes in the ISR touch screen. So, in this way all the events are related to each other, the event messages are being sent to the operating system to let it control all the operations of the ISRs. The third option is RTOS first interrupting on interrupt, then RTOS calling the corresponding ISR, the ISR sending messages to the priority queue of interrupt service threads by temporary suspension of a scheduled task. So, let us see what are the all steps taking place in this scenario. So, an RTOS can provide for two levels of interrupt service routines, a fast level ISR and a slow level ISR, which are FLISR and SLISR respectively. Fast level ISR can also be called as hardware interrupt ISR and slow level ISR is known as the software interrupt ISR. Fast level ISR is called just the ISR in RTOS Windows CE. SLISR is called interrupt service thread in case of Windows CE. This is a type of operating system. So, here this is shown that how these processes are taking place. The use of fast level ISR reduces the interrupt latency, that is the waiting period for an interrupt service, and jitter. Jitter is worst case and best case latency difference for an interrupt service. An IST functions as deferred processor call, that is DPC of the ISR. The ith IST is a thread to service an ith interrupt source call. The ISR in the first in first out, that is FIFO order, that has received the message from the ISR, it will be executed. So, ISR is executed in like the messages will be executed in the order of first in first out. So, now this is shown what is happening, that in the first step the interrupt source occurs, interrupt source calls arrives. In the second step the contexts are saved. In the third step the ISR routine is called. So, this is the code for the ISR, this is the return statement here. Now, in the fourth step the messages event message, all the event messages are message to the operating system. Now, in the fifth step after the messages are executed, messages are sent to the operating system, and then after this the ISTs are functions which are known as the deferred procedure calls of the ISR, these are executed. So, and the ith IST is, that is the thread to the service and to service and ith interrupt source call. So, this is being called. So, this is being executed here, and after this, after the ISTs have been called, now it will again return to the operating system. So, in this way here it will retrieve the context k and run task k again. So, this in this order the ISR is executed and then the ISTs for the ith task is executed and then it returns to the main thread, main function. So, in this way this first of all RTOS first interrupts on the interrupt, then RTOS calling the corresponding ISRs, the ISR sending the messages to the priority queue of the interrupt service threads by temporary suspension of the scheduled task. So, that is why in this we can see that here the IST for the ith task is being executed and there is a return from this here to the main operating system. So, that was all from my side on this topic, from that is the interrupting source calls in case of real time operating systems. In the subsequent lectures we will talk about the other related issues in case of RTOS. Thank you.